As Kirk said, today I'm going to be talking about hatch residue breakout and evaluating their breakout to get the most from our residue breakout. Not really going to be going into the details of the how-tos doing a breakout, more along the lines of trying to discuss why we do some of the things we do, why I like to categorize things, because really our breakout is the last mechanism to really fine tune our hatchery to make it better, and like I call it sometimes, learning from our failures. So um, we'll go from there. And my screen's not really doing what it's supposed to, but we'll deal with it. So when we look at incubation and hatchery, there's a lot of different management guides. You can see, one of our management guides here, the Jamesway manual, many other ones from primary breeders, from other incubation companies, from small flock producers, and a lot of different information out there. And I think one thing we always need to remember is, these are guides. Everything's has a mechanism of it. We have to do the fine touch, the little TLC. We do know that incubation is a science. We know some of the things that are required to incubate and grow embryos, the science side of it, the temperature, humidity, all that. But we also have to be willing to use that information, and that's where the art part of it comes in. An old book called The Art of Incubation. We mix science and art because it's we can't really think we're going to say, okay, our machines work this way everywhere. We do know that different hatcheries and different buildings and different locations under different circumstances often provide us a little bit of a curve to what the science should tell us. So then we have to add the art and we have to adjust. And using our residue breakout is one of the ways we will adjust. So what are the basics of incubation? This is a picture of our screen on our Platinum machines, and going over the basics of incubation. Temperature. The primary role of incubation is temperature. We control it here. The temperature controls the embryo growth rate, faster or slower. I mean, if you eliminate all other aspects of incubation, we really can control how fast and slow the embryo grows purely by temperature. And the other mechanism we control, humidity. Our controller here show we can set our humidity settings. It will help us to control moisture loss. We have to get a certain amount of moisture loss in these eggs for the embryo to develop and grow properly. Remember, we're trying to mimic what happens in nature. A mother hen sitting on eggs, there's a certain amount of moisture loss that has to occur to those embryos. Not too much, not too little. The hen is able to control that through what they call attentiveness. They get on the eggs, off the eggs, more frequently, less frequently, depending on ambient conditions. And because they have to control that growth, and then also the humidity level as well, controlling the moisture loss. The other thing is our ventilation. We can see here how much our dampers open and close. Fans, they're operating the fans to kind of move that air. That really works with temperature and humidity to get that proper gas exchange. We can't get the proper gas exchange with just temperature and humidity alone. Ventilation has to be right. We can't have air moving too quickly. We can't have it moving too slowly. And one of the things too is that I think is the big, not difference, but a big thing that each incubator company, particularly Jamesway, tries to do. We have all these same four parameters turning on the embryo movement and embryo movement and then development of that embryo. All of these things not have to be provided, but in the most uniform manner within that incubator cabinet as possible. That's really the crux of it. How can we get uniform temperature, humidity, ventilation through the machine? That's really the bottom line of what we're trying to do, is maintain uniformity of each of these factors here. And then we can watch these and control these. And we had a webinar a few weeks ago on our controllers and using HatchCom and different things, and how to set profiles and such. So we can do a lot of the things we know that is necessary for the embryo to grow correctly, and we're doing so using basically the same basic components here. Looking at our eggs as we get into a residue breakout, just a little bit about the fertilization process, because I think it's important that we all know this. Hopefully we all do at this point in time, how the fertilization process occurs. You have semination, whether it's artificial or natural insemination. The hen stores sperm, sperm's transported to the site of fertilization within the hen, and then we finally result in a fertilized egg. That fertilization process occurs in the infundibulum, and it occurs within minutes after the yolk is ovulated, less than 5 minutes. Some of the literature will tell you 20 to 30 minutes. It's less than 5 minutes. I've collected enough recently ovulated ova. It is less than 5 minutes. So hen lays an egg, minutes later she ovulates the egg for the next day. And then that egg or yolk then travels down the oviduct. Shell formation occurs through the various parts of the oviduct. The albumin, shell membrane, shell itself are all added to that egg. Takes about 24, 26 hours to complete. The hen's body temperature, 104 to 105 Fahrenheit, is obviously enough to begin incubation of that egg. And so that's what we get when we have a laid egg. We have an egg that can represent up to 80,000, 40, 60, 80,000 cells, 1 day's embryo growth. And this show you here how the cellular development occurs within that egg. So a laid egg has a day of embryo growth. Then what we do with it from that point can really affect our overall hatchability. One of the key aspects, and I'll look at this again in a little while, is making sure we can positively identify between an infertile and a fertile egg. I showed you the slide that shows we have up to 80,000, 40, 60, 80,000 cells development in a fertile egg. That's why we get this little donut ring here. This is a fertile egg unincubated. This is an infertile egg, small, compact, tight area. This is probably really one of the mechanisms I see that may be that people have problems with it sometime in their residue breakout, is really determining what was an infertile egg, what was a fertile egg. If we don't do that properly, we can run down the wrong trail over and over and over. For instance, if we call a lot of infertile eggs early dead, that's a different issue than an actual fertility problem at the farm. I hear people say, well, it's hard to tell on a hatch residue breakout. It can be more challenging. With practice, you can do it. A lot of people do it all the time. I know some people still candle. They like to get a little bit fresher look at true fertility, but it can be done in a hatch residue breakout. But we have to make sure that we differentiate between the two. Years ago, I used to go into hatcheries and I would see in there that, a hatchery manager would say, oh, all the eggs are infertile. They're infertile. We can't hatch them. True, can't hatch an infertile egg. Breeder manager, all my eggs are fertile. A hatchery can't hatch them. And I think for the most part, those days are gone. We don't have the finger pointing as much. Typically, our operations have a breeder hatchery manager that really has to respond to both sides, the hatchery and the breeder. So the bottom line is getting quality chicks. And so making sure we identify this, it doesn't do us any good to try and call more eggs one way or another to kind of protect a hatchery or breeder issue. We have a common goal, and that's to produce chicks, and we've got to have fertile eggs to produce chicks. A little bit about the fertility. I won't spend a lot on this, but there is a relationship between fertility and embryonic mortality. And I've showed this thing a number of times in the past years. This is some research we did a number of years ago. And so where we inseminated hens with different doses, different amounts of sperm. In a naturally mated hen, it's believed that a rooster will deposit between 100 and 200 million sperm in a natural mating. So we looked at different scenarios, making sure we incorporated what occurred naturally, 100 to 200 million sperm. Seminated the hens and collected eggs daily till fertility was gone. So this is 2, 4, 6, 8, 10, 12 days after a single insemination, and then we tracked fertility. The other thing we did is taking now what the natural 100 to 200 million sperm, what we would see is we see out here our fertility, about 8 days, we're still over 90%, and this is artificially inseminated hens. And we see after 8 days, we see this fertility begin to drop pretty rapidly out to 20, 21, 22 days when we typically see fertility gone in hens after a single mating. What was interesting is that we also tracked of these fertile eggs, the embryo mortality. And this red line indicates the percentage of fertile eggs that died in early death, early embryo mortality. So when we got out to 12 days, fertility had dropped, but 10% of those eggs that were fertile would die early embryo mortality. By 14 days, where nearly 20% of any fertile eggs died early embryo mortality. So the reason why I say this is I think most people know this and understand. Older flocks, we typically start to see fertility depress, typically because of infrequent mating. When we have infrequent mating, this is the scenario we see right here. So often, I don't get argued on this too many times. You see older flocks, you see fertility drop, you're seeing early embryo mortality increase. This is really why. It's a biological system. It's not necessarily anything we're doing. It's one of those things we have to deal with from working with chickens and their biology. So the methodology of embryo diagnosis, and just a couple key points here. It's important that the managers have direct knowledge of the breakout results, and also that they can monitor breakout procedure, correlate with the people doing the breakout, and maybe even assist in the breakouts. I'll say one of the hatcheries we went to not too long ago was very impressed that the people calling the data mortality and the manager that trained them, they're all on the exact same page. There was no discussion, well, what about this, what about that? And that's exactly the way it should be. I've been in hatcheries before, been called into hatcheries before, and they say, we've got a big problem. First of all, they say our fertility dropped 10% in 2 days. Well, that doesn't really happen. You know, fertility is not going to drop that quickly in a group of birds. And in investigating that, they changed people that were doing the breakout. And there wasn't a lot of communication between who normally did it and the other people that did it. So all of a sudden in one day, their breakout results looked like they had a train wreck coming. And it wasn't really, it was like unviable eggs were all moved from one category to another, and it looked like a bad, really super bad situation. In reality, it was more normal. So I like to make sure that if the managers can't be involved with it, that they are there enough and there's enough people overlapping that if you have to change people doing a breakout at any given time, everybody's kind of on the same page with this. And that's kind of why we often go do trainings with customers, is just let them, let us see how they're doing the breakout. Are they calling it like we would, to keep everybody on the same page? It's really hard to interpret results when you get them from people when you're not confident that what they're calling as an early dead or a mid dead or late dead is what we would also call that. So we have to make sure everybody's on the same page. This little chart over here, and I'll talk about this quite a bit in a little while. It's not the way to do it, it's my way to do it, and I'll explain to it why. But some of the things we want to look at on there is making sure we record our infertile eggs and dead embryos in one of the 3 to 5 stages, and I'll talk about those. Pips, cold chicks. Down at the bottom of this chart, you see there's a lot of other data there, and I'm not going to say everybody has to record all of that. I see some do more, and that's great. But if you start doing too little, we might lose some areas that we could make improvements if we really know what's happening. So just a late dead chick, why? They have an exposed brain, an anomaly, malposition, whatever. We do need to know some of these things because it really does help us in our evaluation. Maybe not to the extent on some of these, putting up contamination and different things, but this is the kind of the chart I use, and the meat of it I think is up here. The other is important as well, but we'll talk about that in a little while. When we do the embryo breakout and start troubleshooting, this comes in handy all the time. I mean, every time we are really trying to troubleshoot a specific problem, we go back to the same questions. Is this isolated to specific flocks or ages of flocks or specific setters or hatchers or other equipment? You know, somebody says we had all of a sudden had some bad hatches and they came from machines that normally hatch well, and the next time they hatched, they were well again. So it's like, well, it wasn't really necessarily a machine issue. Could be, but what's common? Weather patterns, seasonal changes, changes in management practices or personnel. And I've seen this come back to hit pretty hard in some places where things were done that were necessary, but you make changes one place, you need to evaluate the scope of that, the range of where those changes could affect in other areas. And so make note of that. Yeah, we changed the maintenance guy, we changed the person that's setting eggs at a specific time. You might want to get back to that later and say, okay, so we did change people. So was there something they did? Every hatchery has management practices. They can spew them out and give them to you on a sheet of paper. But what really happens is what's most important. So making sure that we're able to document any changes like that. Does the problem persist? Is it normal? That's a big one to me. What is normal or what should be expected? And if there's any different changes in bird combination. This one, I think, and this has happened to a couple of us, probably more than it should, is that a problem is presented to us. And so we go through all the motions of trying to troubleshoot this problem. Could be this, ask questions. And then we get to a point that it's like, well, how often does this occur? And they go, well, it happened once. Well, okay, that was probably something we should have known in the front. Does it persist? No, it happened one time. Well, we often don't know why things happen on a one-time basis. And I'll talk a little bit about that, a little more about that later. And what is normal? We need to know what is normal. What could be expected, or what should we expect in our operations? Making sure we have an action plan, you know, accurate breakout data, summarized properly, data and analyzed properly, what we're going to do with that data, and then making sure we use the information as a management tool. That's probably the most, well, one of the most important, collecting data properly, analyzing it properly, and using it. I go back to many years ago when I was in university situation. I walked into a hatchery. This was probably 25 years ago, and asked the hatchery, "Oh, so you doing routine breakout?" "Yep, I do them all the time. All the time. I was told I need to do breakouts, you know, how frequently they did them." And I said, "So what do you do with the information?" He goes, "It goes in a file cabinet over there," pointed to the side of the wall. He wasn't doing anything with it. Nobody taught him what to do with it. They just said he had to do it. And so we need to have an action plan. We need to make sure we use our data and information, because it's very helpful in kind of telling us what we need to do and the problem we have. Just some information here, not anything that you would necessarily need to have, but most embryo breakout staging developmental patterns come from a series of books by Hamburger and Hamilton back in the 1950s. Yes, we have a different embryo today, a different chick, a little bit different to incubate that in some aspects, but the developmental stages are the same. Interestingly enough, the stages we see a chicken embryo go through over 21 days, 22 days if you count the day in the oviduct as the embryo is growing, but 21 days in the incubator, those same things happen whether it's a 35-day incubation on a Muscovy duck or 50 some odd in an emu. The same things happen, just that it's stretched out over time, or it might be condensed in a shorter developmental pattern. So this was very helpful in just learning what's happening, when it's happening, and in the order in which things are happening. So what is normal? And hopefully we all fully understand this. You know, we are dealing with a biological system. You know, we cannot get 100% fertility. Now, I've dealt with in my academic career with people that work on a much smaller scale, and I hear people often say, "Well, I have 100% fertility every time." Well, that doesn't happen. There's not an animal species anywhere that has 100% fertility. Dogs, cats, horses, humans, chickens, whatever. We're not going to get 100% fertility. On 10 eggs, maybe, In the grand scheme of things, we're not. Hatch or fertile. I hear people say, oh, I get 100% hatch fertile. No, that doesn't happen either, because we have embryo losses that are associated with biological development, and we'll talk about that. Hatchability, we're not going to get everything to hatch. Chick quality, everything's not going to be perfect. We are dealing with a biological system. There's variations in biology and developmental biology all the time. We don't see it just in chickens, we see it everywhere. And so we need to kind of know what is normal, because 100% perfect is not normal. So what do we kind of learn to expect? Fertility, best case scenario, we might have 1 to 2% infertile. Seen this, seen nearly, 99% fertility. It can happen, a lot of variables that might go into that. Breed strain, age of flock, status, housing, management, feed, all these things could play into that, but we can get close to 100% fertility, maybe 1 to 2% infertile. Now, age here is a big factor. As our flocks age, fertility will drop. It's just a fact of life with our birds. Called senescence, aging in our birds. Egg production goes down, fertility, everything. Embryo mortality, and I'll talk a little bit about more about this and kind of break it down. 4 to 5% total embryo loss is normal. We can't get everything to grow. We're just not going to. Again, there's not an animal in the animal kingdom that has perfect growth of embryos, whether they be in an egg, whether it be in utero, it doesn't matter, is that we will have some embryo loss. So what is normal, what is acceptable? My range is about 4 to 5% total embryo loss is what we can expect. I've seen it a little bit less than this, but this is a very reasonable range, and a goal is looking at our total. And I say total, we break it down, but total embryo loss is like the big one for me, is how much total embryo loss are we experiencing. So looking at this chart, and I'm going to spend quite a bit of time on this chart looking at it different ways. And again, this is not the way to do it. This is the way I do it. And I'll explain to you why I do it this way, and I'll talk about some very important things we need to make sure we do when we do our breakouts. Again, it's all about getting the right data, accurate data, and being able to interpret it properly. So one of our more important things is infertile. We've got to be able to distinguish between early dead and infertile. Those are two very different issues in how we handle them. Our early dead, I break it up into two categories here, 0 to 3 days, 4 to 7. All of it is still first week embryo mortality and has a similar causative factor that will cause our embryo mortality in that first week. So I put the two together. I do like to see them split apart, 0 to 3 days and 4 to 7. But in reality, we put it together and call it first week mortality. We have our midweek, which is generally not significant. And then we have our late mortality, our last week from 15 to 21 days. That mortality then is a different function if we start seeing problems in late embryo mortality. I break them here between 16 and 18 days. That's generally when we transfer. This goes back to a research project I was involved in during the transfer process, where we definitively needed to know, are the embryos, are our losses occurring before we transferred or after we transferred? I was really doing this before. This is the way I broke it up. This point in time really hit home to me that that's a really big time to distinguish our late mortality, is pre-transfer and post-transfer. So my two late categories, I like to split those up to really see what happened after transfer, after in ovo injection, if that's what we're doing. So I think that's important to be able to distinguish those. And in looking at, trying to break our different categories and sections apart, way back, I just try to make things as simple as possible. I think if there's a lot of gray area, there's a lot of room for error. So what can we really just identify that can help us to get our data correct and accurate? So I came up with some things that occur developmentally. And I'll talk about some of these. Remember, I talked about the infertile, fertile eggs, how to distinguish between those two. Again, this gets a little bit muddy in a residue breakout, or sometimes it can, but it's something that we need to make sure we can distinguish between those two. In that list, and I'll talk about these more, one of the things I look at is a pigmented eye. The eye will become pigmented on the 4th day, prominently. Now, can you, if you really look closely, see any pigment in that eyeball in that 3rd day? You can, but it's prominently. When do you just open that egg up and look at it and go, yep, I see the eye? Okay, so it made it to 4 days. It goes into that category. The next one is our egg tooth here on this chick. When does that become easily visible and prominent? At day 8. So if it's there, day 8, it's now becomes at least a mid-embryo mortality. If we can't see an egg tooth, now we're at least less than 8, so we're 4, 5, 6, 7. Those are things I think that are easily distinguishable. Breaking down to our 15 days, and I'll talk about these a little bit more, but just kind of showing you right now, is we see prominent down covering. Probably the grayest area of this, what's prominent. Is there a lot of down covering on day 14? Day 14, yes, there is. Day 15, it really just jumps out at you. There's a lot of down there. Not an enormous issue if you move some of these into the 14, because we don't see a lot of mid, but really you get familiar with a lot of prominent down covering will hit 15 days. And then we have at 19 days, we start to see the yolk withdrawn. This is a 19-day-old chick. We'll see some yolk out of the body. Most of it will be pulled into the body with a little bit remaining. That goes into your early 19-day, late 18 type of situation. But that's really our key that I look for to move me from a 18 to a 19-day at transfer. We should have most of that yolk withdrawn. Not all, but most. So looking at the sheet that I use, and this again, this isn't the way to do it, but for me, it helps me to be able to have very distinguishing factors. So when we have our fertile eggs, donut-shaped germinal disc. If we have a donut-shaped germinal disc, we have at least a 0 to 3 day embryo. If we don't, it's an infertile egg. That distinguishes between those two factors, and that is an important one to distinguish between. Eye pigmentation, day 4. So if we break open an embryo, we don't see an eye, it's now tallied in the 0 to 3 day. If we see pigmentation in the eye, we know it at least made it to 4 days. So now we have pretty definitive ways to separate infertile 0 to 3 and 4 to 7. Day 8, egg tooth is present and prominent. We see an egg tooth, okay, it made it to that 2nd week of mid-mortality. That happens on the 8th day. The 8th day, again, it's prominent. It's very easy to see and distinguish. When I do breakouts with people, they really start digging in and looking. It's like, well, if you have to really look hard for it, it's not prominent. So kind of remember that. It's got to be prominent and easily visible. Day 15, so our chick down becomes prominent, easily visible. That puts us in that 3rd week, that last week mortality, day 15 to 18. And then our next critical factor at day 19, the yolk sac is withdrawn to body, or mostly withdrawn in the body. That gets us into a post-transfer type of situation, 19 to 21 days. And I think that this then breaks apart some of the key factors in there. Post-transfer, pre-transfer, or middle mortality, or early dead. 0 to 3 are really going to be more of an egg age or handling, like the embryos just don't start properly once they get put back in the incubator. 4 to 7, they can start but not finish. So there is some differences there, but they kind of all still fit into the same category. But this kind of breaks us up into the different categories. So each of these factors I mentioned, all will help us determine what eggs go in what category by looking for these prominent and easily distinguishable features. So now looking at, let's just put some data on this chart. Again, I just kind of made up some data. but there's some points I wanted to bring out here. You know, making sure we get a positional effect. We want to know, are these eggs from the top, middle, or bottom? If you really have a concern with a machine and the uniformity of a machine, we can even go further with this. We can say, okay, this is buggy 1, top, middle, bottom, buggy 3, top, middle, bottom, and so on. So we can start looking at a positional effect in the machine between the buggies, but also between top and bottom. So how many eggs are in the tray? 168 is what they should have. If we've had some pull and can account for that, great. But we always need to know that start point. Doesn't do much good to start pulling eggs out without knowing how many eggs they came from. I was called into a hatchery quite a few years ago, and you know, veterinarian came into the hatchery and just said, hey, we've got an issue here with all these embryo mortality, a lot of embryo mortality, or not anomalies, exposed brains. What can we do? So I went to the hatchery. The hatchery manager said, between you and I, it's not a problem, but our veterinarian said I had to come, said you need to come to look at it, so we'll look. So we looked at it, and the biggest thing was that he just gathered them up and put them on flats. We had no idea how many eggs those came from. So yes, we could look at those and say, yes, we see exposed brains and we see, you know, 2 beats and stuff, sure. We had no idea how many eggs they came from, so we didn't know source. We've got to know the data and the source and the percentages they occur. So when we went through and did a normal breakout, not what had been pulled out, we found out he was right in line. Somebody just saw a collection of these and thought this has got to be an issue. Brings the point that I get asked this, and maybe I rudely answer this the same way. In a hatchery, somebody might have an embryo that died, and they go, well, why did this one die? I look at myself, I have the foggiest idea why that one died. Now, let's look at enough data, find out, okay, we have twice as many in that category that died. Okay, now I can answer that. Why did that one die? I don't know. I have no idea, because things happen in biology. We've got to look at our ratios and percentages. So let's look at, you know, 168 eggs hatched. If they're hand pulled, we can say, okay, there was 153 chicks came out of that basket, which in this scenario gives us 15 extra eggs. 5 were infertile, 3 were, you know, 0 to 3 dead, 1 4 to 7. Total early mortality in this case was 2.38%, and this is just a calculation that occurs. Our mid mortality, then our last week mortality, 1 in the 15 to 18 and 4 in the 19 to 21, for a total late of 2.98%. Then the total embryo loss, this number, adding this number to it, will give us our total embryo loss. So we can say, okay, 168 eggs, 153 chicks hatched. All these 5, 3, 1, 1, 1 should all equal, plus 153 should equal 168. So every egg has to be accounted for. That's probably the big thing that that people need to know, is we have to account for everything. You know, when I do a breakout and I pull an egg up, I might spout off and say, you know, malposition, dead pip, exposed brain, late dead, 21-day dead. Okay, so you put a tally in 21 day and then 1 on all the other spots. It died at 21 days. There's reasons it died, but it died at 21 days. If you have chicks that by the time you do the breakout, you got an empty shell, well, a chick hatched somewhere. Do you count it as a hatch chick or a embryo loss? I count it as an embryo loss. It didn't hatch by the time we pulled the hatch. Essentially, to me, it's a dead chick. It's a chick mortality. Right at hatch, it didn't make it. Everything has to be accounted right in this area. We can't miss. We can't. We start counting something somewhere else and not there. We're going to have some funky data. So looking at our embryo mortality patterns, in that first week, we said about 2.5% normal embryo mortality. What's happening here is cell differentiation, blood circulation systems developing, and those are the things occurring in that embryo. If we have problems in that first week, these are potential causes, which we'll talk about again a little bit. This is really to focus on what's normal. Middle should be about 0.5%. And I'll say that in my 25 years or so doing research and working with clients, whether I was at the university or working with Jamesway or whatever, I can't really recall times that there was a consistent breeder nutrition problem. Yes, you have times where breeders are given wrong feed and you get a train wreck of a hatch, but consistently, if the breeders are fed a deficient, extremely deficient diet, you might have some problems in hatch initially, but eventually they're just going to quit laying eggs because they lay an egg to produce an embryo. If they don't have the nutrients to put in the egg to grow an embryo, they typically are going to quit laying eggs. So I really don't see this. It should always be in that 0.5% range when we're looking at 18 to 14 days. When I see situations where it's twice as high or something, I'm like, okay, so they're probably calling some earlies as mids and some lates as mids, you know, along those lines. The 15 to 21 days, the last week, should be about 2 to 2.5% again. That's normal. And this is a time when the embryo is switching to pulmonary respiration, meaning that that chick, up till this point, 19 days, through a date, 18 days, they are respiring through the cam and through the shell. And at 19 days, around that time, when they make that first internal pip into the air cell, that's the first time that they open their mouth and gasp and try and take in air. And that's when their body is supposed to switch to pulmonary respiration. We see the same thing in humans. You know, I don't know if it happens quite so much. My kids are older now, but baby comes out and, you know, often what you always see, oh, they spank the baby, you know, what are they trying? They get it to cry to inspire air to get their lungs working. And our chicks, when they pip into that air cell, that lung's supposed to start working. If that doesn't make that switch, they will die. They can no longer survive and respire on the previous mechanisms they had. So that's one of the main things that's happening in that last week. So looking at our chart again, we had our total embryo loss of 5.95%. This would be our early, 2 earlies, 3 and 1, our mid, our late, early, late, 15 to 18, and 19 to 21. That equals 10. If you add those, we would have to be at 168, so equals 10. And that's a 5.95% embryo loss. What do we say is normal or biological? 4 to 5%. We have a little bit more embryo loss here, and we should. So there are some opportunities here. It's not bad. If these are really old flocks, this may be a little bit more normal situation if this flock was really old. Actually, if it was a real old flock, this might be good. But we're a little bit higher than what we would expect on this one group of eggs. The other thing I will say is we have to really be cognizant of the numbers we're dealing with. In research situations, we have to be very careful to not gather data one day and try and draw conclusions on a whole trial, because there's a lot of variation in one day. We need to look at it cumulative. We typically would break things off for a week at a time to get the ups and downs. Same with our breakout. We can't tell why one chick died. We typically can't figure out what's happening with the whole flock by one tray. So we typically will do 3 or 4, sometimes up to 5 trays per flock in different positions to really get a gauge of what's going on. Why there might be some differences in numbers, it depends on how you calculate it. If you actually add the numbers, you get 5.9%. If you actually use the percentages, rounding errors, you might get a little bit different. This is not a big deal. It's just rounding errors of how we calculate those numbers. So when we look at our total hatch, chicks hatched, divided by chicks per tray, gives us a 91% total hatch. And the reason why I bring this up too is to understand is that there are differences sometimes depending on how we look at our data. Hatch or fertile would be the chicks hatched of the fertile eggs, so 168 minus 5 would be 163, gives us a 93.9% hatch or fertile. And so if we look at 5.95 embryo loss, 5.96, 93.3% hatch or fertile, that's accounting for 99% of the eggs here. Why is that off? Well, again, rounding. If we use the full numerical numbers all the way out, we should be at 100. If we only use the numbers and not percentages like we did up here, we may also, you know, be a little bit off or get 100%. But when we start using rounded figures, we could be a little bit off, which we shouldn't be too far off. So our hatch fertile and our embryo loss should draw a correlation between the two. So what does our normal mortality patterns look like? From 0 to 21 days. Again, that 2 to 3 days, we have the cell differentiation. So we have some biological losses that occur there. Switching to pulmonary respiration here at 18 to 19 days. When that doesn't occur, we get losses. Hatch problems. The chicks are oriented improperly, malpositioned, eggs set up down, upside down, other things with incubation. They just fail to hatch even though everything else occurred. So the combination of these should be 4 to 5%, but this is like roughly a normal hatch pattern. So when we're looking at trying to troubleshoot, typically that first week is egg handling. When I say egg handling, it's like, okay, from the time the egg was laid until it was put in our incubator, all the things in between, farm storage, transportation, hatchery storage, movement into the machines, whether we pre-warm or not, whether we do it properly. That's all egg handling, how the egg is cared for and handled from the time of lay to the time it gets in the incubator. We should, under normal circumstances, normal egg age, we should have 2 temperature changes. From the hen house, the next temperature should be decreasing. The egg workroom, on-farm egg room, egg truck, to the hatchery, every next step should be lower than the previous one, so they're slowly being cooled, and then by the time we start warming them, they should go to the hatchery. When we see elevated early embryo mortality, we can look at egg handling. The other thing we can look at here too is we may often see some poor fertility as well. If we have poor fertility due to infrequent mating, remember the data I showed you earlier, for infertility is going to go up and early embryo mortality is going to go up to infrequent mating. So again, that's not necessarily egg handling, but that's before the hatchery. That midweek, nutrition. I'm not going to spend much time on that because we typically just don't see elevations in nutrition. And then that last week, that's when we really start looking at incubation. Is this completely isolated? Can we have egg handling issues that elevate embryo mortality in the first week and also in the last week? Yes, we can. Majority of the egg handling issues will be in that first week, but you will often see a little spike later as well because some embryos were stressed. They didn't die early on, but they died later. One of the reasons why I really like to look at total embryo loss, I have seen situations where people had extremely low early embryo mortality, but a little bit higher last week mortality, and their total embryo loss was about 5%. They're like, well, do we have a lot of room for improvement? Possibly, but you're in that 4 to 5% range of embryo loss due to biological function. So I like to really look at the combination of the two because I think it's important for us. Again, this is the causative factors of why we see embryo loss. Looking at our single stage and multi-stage, and this, people ask me this and they go, well, why is early dead embryo early mortality higher in multi-stage than single stage when it's pre-incubator? Yes, our single stage incubation can get our eggs restarted up after storage more uniformly and in a more controlled manner. So when we have higher embryo mortality here in multi-stage, is it the fault of the multi-stage machine? Not necessarily, probably not. I've tried to kill embryos early on with bad temperature. But the multi-stage is a less controlled environment of bringing the eggs up to temperature, getting them restarted. So if we have egg handling issues, long storage, temperature of use, maybe even rough handling, they're more likely to fail in a multi-stage and a single stage, but it's not the incubator's fault. The incubation, the single stage, just has a little bit more room for error because we can incubate eggs a little bit more for exactly what they need. So again, breaking them down to categories here. So let's go back to this chart real quick. That first week, everything in this first 2 days, egg handling. That middle week, nutrition. that last week incubation. This type of a chart helps me to really categorize where the issues might come from. You know, when we start bleeding over from one category to another, it gets a little bit muddy to try and, you know, troubleshoot and figure out what's going on. Again, we've got cell differentiation, we've got hatch problems occurring in these two categories here. So going kind of quickly through some of these things, fertile eggs, see the germinal disc, see the development of the germinal disc. It will continue to grow from this ring and eventually encapsulate the whole yolk as it continues to grow. Day 3, when we see mortality at day 3, what are some of the things that are occurring? The heartbeats, blood vessels are very visible. We start seeing high embryo mortality there. Again, low fertility, like I talked about. Some pre-incubation, poor egg storage, improper egg holding time, long storage. You know, we'll start seeing these embryos start, but they just can't continue. And so we'll see the initial stages of growth, and then we see them drop off pretty early. Day 4, again, that's where we see the eye tooth pigment. This is the eye tooth here. A little bit more visible on this one here. Similar problems as the day 0 to 3. I split the two up just because I like to look at it, how many are really in those blood ring stage and how many develop a little bit further, but it's all still a first week mortality. Day 8, we're moving into midweek. Of course, the eye is pigmented, but we also see the egg tooth. Why would we see problems here? Could be temperature if it's late, mid. You know, if I had real temperature abuse, I could get some of the embryos to die at, you know, 9, 10, 11 days when I had really low temperatures, really high, or as early as 8 or 9 days. But we're talking about extreme temperatures. And it could be nutrition. Again, I don't see a whole lot of mid-mortality. Day 15, again, guts drawn into the body cavity, chick covering is prominent, very noticeable to see. If we start seeing a lot of problems there, we treat that similar to our mid-mortality. Could be a nutritional thing. Again, some developmental problems just occur. That 19, yolk sac draws into that body. Amniotic fluid's gone. If we see a accelerated or increased mortality at this stage, a lot of times it's failure to switch to pulmonary respiration. Some of it's just going to happen. If not, we could have a vaccination issue if we're using an OvoJect. Inconsistent transfer, long transfer times. The eggs are getting cooled, chilled, a rough transfer. Proper temperature, humidity, and ventilation in our incubation period can kind of stall or cause some developmental problems as well. So a number of things that can happen here that can cause 19-day. You notice these are primarily incubator or incubation issues. Day 20, most of the yolk is drawn into that body. Typically, we have an internal or an external PIP at that point. If we have elevated loss there, hatchery ventilation temperature, we can go back to our incubators as well. Some turning temperature, humidity issues. We also can look at, from the breeder side, maybe shell quality issues. We have a lot more broken eggs, a lot too high moisture loss because of that. Time of transfer, hatchery ventilation. So we have a couple things here that can cause elevated mortality in that 20 days. Again, trying to get everything in the right category here. So real quickly, as we're trying to wrap up here, trying not to take too much time, just briefly go over some things and kind of walk through why we might see that and creating a big picture of what could be occurring. What if we see a lot of unhatched pipped eggs, dead in the shell, full-term embryos, but they just failed to hatch? Low humidity or temperature for long periods. Understand the temperature. What happens if we really decrease temperature? We really slow down embryo development. When it's time to pull that hatch, they just never quite made it to the time developmental stage at the time the hatch was pulled. So temperature could control that. Humidity also. Low humidity, they could have excess moisture loss. The chick just couldn't develop right, couldn't get in position to hatch. Could have hatchery humidity low. As the chicks were trying to hatch out, they dried out, they got stuck. High temperatures during the hatching process. Chicks are trying to hatch, they're hot, we're not cooling them properly, they get exhausted and worn out. Poor ventilation, we could have hot or cool spots in our incubator. So thinking of how our incubation process works, and we're saying, okay, we've got chicks that are dead. They could be delayed. They could have been stressed during the incubation period by temperature or poor ventilation. Also, prolonged egg storage. If you store eggs too long, it takes longer to hatch if we don't adjust for that on our set times. Malpositioned chicks. Head in the small end of the egg, head to the left, not under the wing. What's a probable cause? Eggs set small end up. Fortunately, now with most places, we use an ovojection for vaccination. And we can tell if they were set upside down or not. And that is a big cause of upside down eggs. I think upside down embryos. I think most of the time I see that it's because eggs were set upside down. What about other malpositions, not upside down? Old breeders, turning, failures in turning, temperatures too high or too low, humidity too high, it affects our moisture loss and the embryo growing and filling out that shell. Also, we get a misshaped egg, round shaped or very large eggs. Sometimes the embryo has a hard time orienting properly. Very slow hatch. Again, let's go back to what is controlling our hatch. We could have mixture of eggs stored too long and too short. We need to look at that. Mixture of eggs from young and old breeders. We need to look at that because these will have different incubation times. Mixture of large and small eggs related to this area. Improper egg handling. And the other thing here is hot or cold spots in the setters or hatchers. And sometimes that is a hard thing to see. This would be something I would follow up with doing a breakout of eggs in positions in the machine in different buggies if we suspect that. If we don't have proper ventilation, we could have areas in that machine that just don't get the heat. So some of the chicks are very slow to develop and hatch, and when it's time to pull them, we lose a lot of hatch. We may also have hot spots, which then would give us an accelerated hatch on. And so kind of going back to what's going on in the incubator, what would make a slow hatch? What would make a draggy hatch, wide hatch window, ununiform incubation temperatures and development of the embryo itself. Open or unhealed navels. The setter temperature could be too high or a variation in temperature, meaning hot and cold spots. So you've got areas in there that are too high. Your set points might be right, but if your ventilation is not proper and you don't have uniform ventilation, we can most definitely have some of these unhealed navels. Hatcher temperature, low. They don't finish off right. They don't get that last little withdrawal of the yolk and closing. Humidity too high. They're not losing the moisture. And so when it comes time to really close up that embryo, there's just too much mass of moisture in that chick and it really can't heal up that navel properly. And so we could have some open or unhealed navels. Some of the things I think most of us look at routinely in our hatch residue. Red hocks, and a lot of different signs of things with red hocks and what could cause it. And really the bottom line is why does that chick have red on the nose or cere or on the hocks? They had a hard time hatching. It could be thick shells, young flocks, it could be humidity, it could be temperature, anything that causes that chick to struggle to hatch. So I would say this because is the low setter temperature making their hocks red? No, it's making them have a difficulty hatching, which there's a wear and abrasions on the hocks and on the nose. So it's a difficulty hatching. So we go back and look, okay, why did they have difficulty hatching? We will often see some of the other things we talked about, slower hatch or unhealed navels in association with that. Brain hernia, exposed brain. Temperatures too high, particularly early. If you have hot and cool spots in machines, particularly in multi-stage machines where they're moving through a machine at different stages, if we don't have proper ventilation, we're going to have a stage where we might have a hot spot fairly routinely, and we get a lot of eggs or chicks that develop that early on, and they get exposed brains. The developmental patterns of the skeleton and everything is not quite right, and so we get some abnormalities, and these can be pretty severe as well, not just small like this. CO2 can cause that turning problems that may also result in hot and cool spots in the machine if they're not turning. Some of our benefits of turning are really to adjust and adapt our ventilation through the machines, to change it all the time, every time the eggs are turning. Could be equipment malfunction as well. Kind of summarizing this real quickly, and then we'll get to some questions, is we've got to have proper data, and it's got to be accurate. And we need to record it and express the data as a percentage. Again, when people say, why did this chick hatch? I have no idea. Well, they tell me, okay, we had 3% exposed brains. Okay, that's an issue. If you hold one chick up, why did that I don't know why. We have to have accurate data. We have to have it so we're confident in it and express as a percentage of what's going on. It doesn't do any good to just, I've seen people send a basket of cold chicks and they said, look at the chicks we're getting. My absolute first question is that all the cold chicks from the entire day's hatch? Or is that from a 30-minute span or a 10-minute span of light? That's a huge difference. You know, how large of the sample size did that come from? As a percentage, we've got to know, because sometimes just our numbers, unless we know the base where they came from, can be very deceiving. What is normal for the hatchery? We've got to know what's normal. You know, if all of a sudden we're like, I don't think this is right, and they go, well, what do you normally get? Well, we're not really sure because we haven't done breakouts on it. Well, you need to do it enough to know what is normal so you can recognize deviations. And if you start taking corrective actions, you know if you're getting back to where you should be. Evaluation, comparing the areas of concern with the embryo development patterns and stages of incubation. So you've got areas that are like, okay, we're getting slow hatch, or we're getting malposition. You know, what do we know about embryo development pattern and stages of incubation? What can cause that in the developmental part that can cause the issue we have? The other thing, going back here, is reacting, and I'll mention this on this point, is drawing correlations with our embryo breakout patterns and on-farm 7-day livability, and then react. And we need to make sure here we combine everything together, because I've seen, especially in the last year or so, you know, people trying to say, okay, we have this issue on the farm, so we think that it's high temperature in the hatchery or something. That's what we think is going on. Well, did you notice anything else from your residue breakout that would indicate high temperature? And if they say no, everything looked completely good, well, I just have a hard time believing that 2 or 3 weeks later something's going to happen to them and it's all the fault of the hatchery. Combine everything together. You know, if we're going to see problems in a hatch of poor chick quality, we're probably going to see poor 7-day livability. If we're going to see really good chick quality, and then we see some 7 or 14-day problems, you know, I want to know why we didn't see it early on, because there's a lot of cues and clues we have there. So putting it all together in one package will help. With that, I think we can entertain some questions. Hopefully Kirk's around the corner somewhere and will join us. Let me stop sharing the screen. Okay.
Thanks, Dr. Bramwell. That was a great presentation. We do have several questions, and we'll get to as many as we can get to.
I might just have you answer some of them too. I don't know, just the fun of it.
The ones we don't get to, we will get answered and get them back to you if we run out of time. First question, Dr. Bramwell, is egg age after 7 days. Is that also a factor in fertility?
Egg age, or
does an egg lose fertility after being stored for 7 days?
No. When an egg is fertilized, and that's when an egg is fertilized right after a hen lays an egg, it's fertilized, like I said, within 5 minutes after that, and that fertility has occurred. Once albumin is put on that egg, fertilization process is over. It can't occur. It also can't be undone. And, you know, and I like to go and look at and say, okay, when an egg is laid, it has the maximum hatching potential it will ever have. We can do a lot of things after that to make them hatch worse. There's nothing we can do to make them hatch better. So if they hatch worse, they don't lose fertility. Fertility already happened. What you're probably seeing is if we're getting past 7 days and you're thinking they're less fertile because it's past 7 days, you're not able to distinguish between the really early deads and the infertiles as well as you thought you were. But the eggs will not lose fertility the longer they're stored. They will lose viability, but not fertility.
Okay, thank you. The next question is, what is the ideal amount of eggs to sample for a breakout?
Well, going back to my research days and use of statistics, it's what you're comfortable with. I think most people will do a 3 or 4, hatch basket sample for a flock. And people ask me, well, is that adequate? And I'm like, well, obviously, 3 flats or 3 trays is better than 1. 6 trays is better than 3. All of them is better than 3 or 6, but we can't do all of them. That's going to be the most accurate. So we have to find what we're comfortable with. If you're doing a 3 tray sample and the hatch you're getting out of that is pretty far off from your actual hatch, well, maybe you ought to add another tray and see how close we start bringing those together. For mine, it's all a matter of what's practical and what would be done. I think most people would do like 3 or 4 trays from a specific flock of machines, and that's mostly gives you a pretty accurate sample if you kind of randomize them throughout.
All right, thanks. Next question. Normally a breakout, residue breakout is done, after hatch. But in critical cases, is it feasible to do a breakout at 9 days or 18 days, like right at transfer? Is there anything gained or lost there? Is it worth doing?
Again, that's a economic decision. I would say, is it worth doing a breakout at 10 days to get a better access to fertility? A lot of people really think it is. Hey, if I break them open at candle and break them up at 10 days, my fertility and infertile are more accurate. And that's probably true because you don't have another 10 days of degradation of that embryo. So yes, you'll gain that information. Well, if you do an 18-day, I don't know that that's going to be any better than a residue breakout. But do you gain any new information if somebody's doing a candling, 10-day candling, and a residue breakout? Everything you get at the residue breakout, you're getting the same thing at the 10-day candling. So the 10-day candling is not giving you any new information. It's just that people feel more comfortable doing that, but it's costly. Man hours, disruption of the machines in some cases. So I wouldn't necessarily say you gain a lot from it, but I know people that do it. Some people do it in different species, pheasant, things like that, to get a projection of, their hatch coming out to meet demands. Okay, I can buy that, but you're not gaining anything new you're not already getting with the residue breakout.
All right. Early dead and infertility is always debatable. What's the best way for a hatchery manager to differentiate
between infertile and early dead?
Yes.
Well, if they're having a hard time, let's say if somebody really using a hatch residue breakout is having a difficult time really differentiating the two, what I would say is whoever's doing the breakout, do a trading, set some eggs for, in a machine for even 3 and 4 days, 7 days, set a few in there, break them all open and get a really good handle on what they look like before the embryo really breaks down. Honestly, if an egg is incubated for 24 hours, you break open a 24-hour fertile egg that's been incubated 24 hours and an infertile, they're vastly different. You can tell after 24 hours if you break them open. That's what I would say is really break them open at the younger stages to get a better clue and an understanding of that. Because I'll admit, once you get out to 21 days, if that embryo dies in day 1 and sits in an incubator for 20 more days, it doesn't look all pretty like most of the pictures show us. And so we have to get comfortable with that. But I would just say back up and do a self-training with some younger ages and get a good handle on it.
Okay. Next question. In a hatch analysis, do we need, I know you've got a lot of great spreadsheets that you've built that, dial it down to exactly what the issue is. But in a hatch analysis, how do you account for like transfer cracks, as a fertile, or would that be added to a crack only with no embryo? How about the rotten with an embryo also?
Good question.
Just
Yep.
kind of things like that. I know that's a hard, real broad question, but you got a lot on your sheets there to differentiate between many causes.
No, that's a great question, and then I do get asked that, and my biggest thing is kind of be consistent with it. For me, if I'm breaking open eggs and I see, a farm crack or transfer crack, a lot of times you can look in there and say, okay, was there any signs of development at all? You might see it, you may not. Contaminated eggs, I see people go both ways with the contaminated eggs. So like, oh, it's an infertile. Well, most hatchery people are going to say it's contaminated, so it's contaminated and it's infertile. Really, 9 out of 10 eggs are actually fertile. So if you've got a contaminated one, but you're calling them all infertile just because, maybe you're helping your hatchery out by saying our fertility is not as good. To me, 90% chance that egg was fertile and something was growing there. So consistently, I'll take contaminated eggs and I'll call them fertile, early dead, contaminated. That's what I do, but I think having to make sure everybody's on the same page so we don't see a change in there. Transfer crack, same way. I'll break it open and look. Do I see something in there? Most of the time you can. If not, and it's not obviously infertile, I wouldn't lean on the side of an early dead because 90% or better of them are fertile. So, odds are if you call them all that, then you're more right than you're wrong.
Yeah. All right. The next question. What is the main cause of chicks being fully formed but dead without pipping? Besides it being a humidity or a temperature or ventilation issue, what is the biological cause? I guess is where they're going with this, if there is one.
Again, it goes.
Hatcher or
Well, it's definitely going to be an incubator. Definitely be an incubator-ish. I would say definitely because when does the internal pipping occur? Right about transfer time, roughly there. If they never get to that point, I would say most likely it's not a hatcher issue because if you got improper conditions at 20 days or so in the hatcher, well, that thing should have been pipped a long time ago. So typically it's pre-hatcher if you don't have that. If you have unpipped and no internal pip, nothing, and you have a lot of them, I just look at the embryos. Are they really wet? Have they lost the proper moisture? Start evaluating that to make sure you just don't have too much humidity and they're drowned themselves. Remember, though, that at that point, they've got to be positioned right to make that internal pip. If their head's positioned wrong, they're improperly oriented, they're not going to be able to make that pip either. If they can't make that pip into the air cell to get air, and because they're positioned wrong and they're pipping somewhere that's not an air cell and not through the shell, they can't initiate pulmonary respiration and they're going to die as well. So you have some factors there that take into account malposition and moisture loss and things like that that can occur. That if you have a lot of them that are just dead, fully developed and dead, I would have then look at the rest of your data. Do you have a very wide hatch window? If given more time, would they have hatched? Or did you have chicks coming off extremely early? Meaning that you probably were a little warm in your machine. Those got a little bit hot. Maybe you have some hot and cool spots in your machine. So it could go a couple of different ways, but remember again that time period, there's a biological factor that has to occur. And some things in our incubation system can actually make that worse than just biology. So I don't know whether to answer that question because it's not a very definitive answer. There's a lot of factors that play into that.
Okay. What is the typical causes of malpositions, even if the egg is not set upside down, like head over the wing instead of under the wing, or head turned to the left?
I would say it could be your turning issues. If you're not turning enough, you've got some racks that are have a short turn. They're not getting up to 43%. If they're quite a bit less, they're not able to orient themselves properly in there. You could also have, shaped eggs. You get a lot of real round eggs. Chicks have a harder time orienting themselves in those eggs. So most of your malposition is going to be a turning issue. or you know, an egg itself, the egg pack itself. But I would lean more to turning than anything else. There are some other possible factors in there, but that's kind of where I would lean.
Okay. All right. If a few feathers are seen while doing the breakout, how would you classify that one? Late dead?
If
Which one?
if there's if you've got, okay, so back to my breakout sheet, if you can notice an egg tooth, it made it to 18 days, but you don't notice significant down, you know, you're looking at probably a 10, 12-day embryo death where they never got to that phase where they're really, you know, producing significant down. So that's going to go in your mid. 15 is when you really like, okay, we got a lot of chick down on this chick. We hit that 15-day period. So if they don't have much on there, then, you know, you're looking at something before that. The other thing too is that what I think sometimes in doing our breakouts, we need to make sure that I've seen people try and gauge a dead embryo on size when developmentally, okay, it's got an egg tooth and it's got a lot of down. You know, it looks, you know, mostly normal, the down and everything is just really small. They might say, well, it's small, so it's probably a 10-day or something because it's really small. Well, if you've got all the developmental patterns that push it back 15, 16 days, it's just small. You look at the development of that embryo, not the size of it, of when it died, because it probably still died when the development indicators were there, a lot of chick down, but something along the way wasn't letting it have the proper growth and everything. But what does the development tell you about what stage is it in? And it's not necessarily size as much as what's happening on the embryo.
Okay. Let's see. What hatchery management interventions can be done in the middle of embryonic mortalities? Like, what issue should it be addressed on the farm? Should it be addressed at the hatchery?
If you have midweek, second week,
yes.
Without
a lot of mid dead, elevated mid dead.
Without sounding mean or something, I don't know, judgmental, I would say go back to look at how you're calling your embryos. If you're showing 2% mid dead, I'm pretty certain that we can sit down and do a breakout with you and determine that a lot of those mids are really earlys or lates. Because I mean, in 20 something years, like I said, I haven't seen that 2%, 1.5 to 2% mid mortality while hens are still laying eggs at an acceptable rate and the fertility. It really doesn't occur. And so to me, it's like, okay, so where are we calling these wrong? That's the first place I would
go. Okay. How to reduce open navels during the winter, mainly during winter seasons?
Mainly during winter. We got a lot of open navels. That's where you go back and look. I mean, and not whether it's a multi-stage or single stage, but you start looking at your hull temperatures and humidity, your machine temperature and humidity. A lot of people will make adjustments for summer and winter. I know you did when you were a hatchery manager, Kurt. So if you have somebody that said, hey, we're seeing a lot of open navels at this time of year, we don't see them at other times, well, you probably need to make some adjustments to your profiles, humidity, your temperature, probably in your halls and everything, because even though we build these nice, beautiful hatcheries that we're supposed to be able to control, most of us know we can't completely control the hallways conditions. They do change from summer to winter. Go back and look at what's going on there. You got a lot of open navels. Okay, what are you getting in the summertime? You might need to make adjustments to get back to what you're seeing there. That's where I would look at maybe even your profile, you know, humidity and temperature in your profiles too. But definitely something's happening in your machine or in your incubator in your hallways, most likely, that's causing the machines to not operate as they do at the other times of the year. So be a number of factors.
All right. How do you evaluate the pulmonary development at 18 to 21 days?
Like pulmonary respiration development?
Yes.
If they hatch, then it worked. I mean, really, because they're if they develop all the way to 18 days, develop normally, they're a good sized embryo. All the developmental patterns occurred, you know, and then they pip and they just their internal pip and they're just dead, to me, and you pull open and the position is right and everything else is right, that's where I would look and say, well, they just didn't initiate that pulmonary respiration on that pip. That's really the only way. I mean, could you start cutting some open and looking? You possibly could, but I think the pattern right there is just seeing it never was able to intake oxygen and initiate that pulmonary respiration. It's really your breakouts when they occur. Again, if you have a lot of internal pips and not hatching, that could be an indicator of that. But can we adjust that incubation and make that switch to pulmonary respiration by something we do incubation wise? I don't know that we necessarily can. That's a biological thing that everything has to be lined up right and developed right to make that switch.
Okay. This next one, how to improve hatch of fertile in 15-day-old eggs. Don't set 15-day-old eggs, number one, and you'll improve that. But some people don't have a choice. So
right.
I never had much success trying to incubate 15-day-old eggs. It wasn't in my favor most of the time.
Yeah, and I'll say another thing on setting 15-day-old eggs is not only your hatch of fertile is going to go down, your hatch is going down, your hatch of fertile is going down. We did some research a number of years ago that showed if you store eggs for 15 days, even those broilers that hatch have poor performance. They have higher 7-day mortality. They have poor growth rate. So you can't really win doing that. But like you said, sometimes you don't have a choice. If you're storing eggs longer than, I'd say 10 days, you need to do a Spidey's program. That's the short periods of incubation during egg storage, to where you're implementing some spikes in temperature to get those cells, the embryos, to regenerate and repair themselves and get the cell numbers up. It's a very well-developed process. We can send, if you're interested, we can send you some information on that Spidey's program, how to improve that. Now, if you said eggs are 15 days old and implement Spidey's, will they hatch like a 3-day egg? No, but they'll certainly hatch better in a 15-day-old egg that you did not do Spidey's with. Quite big improvement as well. So first, like you said, don't do it if you can. But if you have to, yeah, I'd definitely look at a Spidey's program during storage for the old egg. Now, that's really for your old eggs. It's not really going to help you on 5, 6, 7, 8-day-old eggs, but 10 and beyond definitely will help. Okay,
so now the next question, we're going to go to the other end of that spectrum. What's the minimum days of storage to get better hatch? And is it necessary to store eggs immediately after egg is laid? What happens if I set them too fresh into the incubator? I kind of like for all of my eggs to be all together in one place for 8 or 10 hours. That way they're all the internal egg gets to the same temperature, all of them do. That way they all start incubating at the same time. Number one, that's what I like to do. Right. But go ahead.
Well, biologically, you think a hen will lay a long clutch of eggs, and so they do that knowing that most of those eggs are going to have to sit for a period of time. So there are some chemical changes of that albumin that need to take place. Changes in pH is one, to prepare it to be more conducive for embryo growth. So if you take an egg directly out of hen and set it, that egg is not going to grow and develop as well as it should, because the albumin there is not prepared. The egg is supposed to sit. So when I've done data and looking at the chart, the second and third day will be your highest hatchability. That very first day the eggs were laid will be a little bit lower than the others. Now, knowing that and sharing that data, you probably had to do this, Kirk. I know that other hatchery managers are like, well, I know that eggs right out of the chicken house don't hatch as well, but I'm short on eggs, so they're going to the incubator anyway. Okay, understand that. But if you can avoid setting eggs the same day they're laid, they definitely will be better. They need 2 to even the third day. The second to third day after lay is when they're best. You best hatch. Right. We do what we got to do,
Oh yeah, sure. Next question. Is it valuable to segregate head over wing from other malpositions?
Valuable to what? Sorry.
To
Separate the
segregate it, classify it different in your breakout.
um I would say if you're seeing a lot of it, you're saying we're seeing a lot of malpositions here. Um, it wouldn't hurt to start creating a new category to say what really are they. I think for most people that are looking at, less than 0.5%, 0.4, 0.3% malposition, do we need to separate those, head not under wing, head turned to the left, whatever? I don't think that's important unless that number starts to rise and say, man, we've got, 0.75% or higher malposition. That's when I would say, okay, we're having an issue here. Let's further investigate that and create another category. As a general rule, I don't think it's necessary. I think it's great if somebody has a spreadsheet with 100 categories on it. I mean, if they want to do that, that's great. The more, the merrier. But what concerns me is when you start trying to do too much, you don't do what's necessary as well. And so, I would separate them out if needed, but I wouldn't necessarily create another category just because, it's not important unless we really see a issue.
Okay. Let's see. Next question. There's still a lot of questions here.
Yeah, if we don't get to your questions live on here, we, our wonderful behind the scenes, Chris will send us your written questions and we'll be able to reply to them by email. So we'll get to what we can, but.
Okay.
Sorry, I was doing the host job right there. I took over your role, Kirk.
Nah, yeah. No, you did great. I was going to say that. We'll take a couple more and then we'll answer the rest of them that way. What is the best set point temperature and humidity for a multi-stage machine, setters, and hatchers? All that's going to depend on your geographical location and
Right.
what you have to do to achieve what's best for that embryo. That's a really, really tough question to try to answer because, what you do in Georgia and what you do in Nebraska is going to be two different things. But
and I was gonna deflect that back to you, Kirk, because I know you've managed multi-stage machines, but some of the variables in there, like I said, it's a tough question because we typically can say, okay, there might be certain set points we might have if you got a lot really high fertility and you got a lot of heat going to be produced in there. You might make an adjustment of lowering that set point temperature, and if you've got really bad fertility problems where you're lacking in the embryo heat, you might raise your temperature. That's where really looking at your crossbar temperatures in your machine. Another way of the art of incubation, we know what they're supposed to have. Okay, let's see what's really happening here and make adjustments there. But I don't think, correct me if I'm wrong, but I don't think there is a best temperature because there's so many variables in there that you need to play with.
Yeah, it's not. And, a lot of things have come a long way now doing embryo temperatures and, knowing what your goal should be there and adjusting that machine, and not only just the machine, but adjusting the hallway that the machine is in.
Right.
To be able to achieve your goal for that embryo temperature, whatever you have to do to reach that, that's what you need to do. That's where you'll find success.
Right. And I've been in hatcheries before where, and I think if machines aren't operating right, you figure out why it's not operating right. But I've been in hatcheries before and they say, yeah, these machines at this end of the hall, we have a different set point than the others. Well, I would like to figure out why, but some people just said, we just know that it's different. So we have to have a different set point there to get optimum hatch. So even within hatcheries, I know some people will use different set points depending on need and situation.
Right. We'll take one last question right here. And I think it's probably a pretty important question.
If I answered my questions shorter, then probably could get to more of them, huh?
No, you're doing great. At what time is there embryo mortality with lack of turning or improper turning? Now, I know typically after 14 days, they say you don't really have to have turning, and it doesn't affect them as much. So definitely before that, and is early on, the problem will get worse the earlier it is typically in incubation. But go ahead, Keith.
Yeah, to really get more, anybody out there that's really wanting to know a little bit more about turning, we had a webinar about a month ago, 6 weeks ago, something like that, on specifically on turning, showed a lot of data and research on that and the needs of when to do it and when to not. So that would be a good resource if you're having a lot of questions on your turning. What Kirk said was exactly right. The embryo really doesn't need to be turned after, I say, the first 2/3 of incubation, depending on whether it's a duck, chicken, turkey, whatever. So in chickens, after 14 days, they don't need to be turned. The embryo doesn't. A lot of the benefits of turning, I think, that we don't give enough credit for is, especially in our big machines that's like behind you, Kirk. Every time we turn in a machine, whether it be a single stage or multi-stage, you're slightly altering your air patterns and movement through that machine. And so the turning of it, every hour, do we need to turn every hour? Can we do it every 2 or 3? We could probably do it every 2 or 3. But the benefit for the embryo, but the benefits of doing as frequently as you do is every time you're changing your air movement patterns, which is helping to create a more uniform environment in your hatch cabinet. I think turning early on is probably more critical. If you're just saying, okay, when is the most important time? In that first week or 10 days, but the latter part, it's not critical for the embryo, but it's definitely beneficial for the embryo's growth and development. When you're talking about the collective group in a machine, it really creates a better environment in our machines.
And it's always good to check turning on an odd hour and an even hour. What I mean by that is 7 o'clock, that's an odd hour, 8 o'clock is an even hour. Write down which way they were at 7, right, or which way that particular machine was at 7. Go back at 8 and make sure that it's turned the opposite direction.
Right.
Because if you just open the door and you say, oh yeah, they're turned, that don't mean they're turning.
Yeah.
You could be stuck in that one.
Yeah, if you check them at 2, 4, 6, and 8, they're always going to be in the same position, you might think.
Right. That don't work.
And the other thing too is that in your machines is making sure they're turning enough. 45 degrees is what we say. 43 is okay, and I think in our webinar we had a month or so ago, anything over 40% really is adequate for that embryo. But you might say, hey, they're turning, but you might have some buggies in there that are turning less than 40%. So that's when you could come into some embryo development problems, malposition and things like that of the embryos, because they're not getting that full turn like they should. So not just checking that they're turning, but checking that they're turning enough.
Correct.
It's important.
Dr. Bramwell, I really appreciate you doing this today. I know it's a little bit different for you being on the other side of the screen.
Oh, yeah, that's all right.
Certainly different for me being on this side of the screen, but
yeah, we switch roles for a little while here, so yeah, it's all good.
But I have enjoyed it. We will get this out. We'll email out a PDF copy of this, and also the link to the YouTube video of this same presentation. It's been recorded, so just be looking for that in your inbox in the days coming. And with that, I thank you, Keith Bramwell, again for all that you do for us here at Jamesway. What a great asset you are. And thanks to all of our customers and other people in the industry that watched today.
Absolutely. Thank you all for participating. Thank you, Kirk.
Thank you.